Okay, today I'm going through this topic on heat and temperature, which is also one of the P4 topic tested in PSLE. So the question is, heat always travel from a region of higher temperature to a region of lower temperature. Heat is not a form of energy. Heat is a form of energy, okay? It is not a matter. Okay, so that means it does not what? Have mass and does not occupy space, because matter occupies space and has mass, but heat is not. So that's why heat is not a matter, but is a form of energy. When an object loses heat, its temperature drop, okay, or decreases. Okay, you mentioned decreases, right? Okay. Similarly, when an object gains heat, the temperatures increases. Next, most good conductors of heat are also good conductors of electricity. Okay, this is what we have learned in primary 5. And a material which is a good conductor of heat, example, aluminum, loses and gains heat faster than a poor conductor of heat. Air is a poor conductor. Okay, I noticed some children in my class, they put good, but actually air is a poor conductor of heat. So they got to take note of this. Air is a poor conductor of heat. Okay, next, we have the number 7. Water, wood, plastic, and ceramics are also poor conductors of heat. Okay, so these are the answers for this page. Okay, water, wood, plastic, and ceramics are also poor conductors of heat. Number 8, only good and poor conductors of heat. So there's strictly no insulators. Okay, insulators we only use for electricity, remember? So for heat, we do not say insulators of heat. We say either they are good or poor conductors. With the same amount of heat energy, gas expands the most, followed by liquid, and the least is solid. That means if you supply the same amount of heat energy to these 3 metals, of course, they must be of the same mass. In order to have a fair experiment, gas will expand the most. So we need to know the difference between heat energy and temperature. Usually they test. Okay, so heat temperature is the degree of hotness or coldness of an object, but heat is a form of energy. So you can see here, let's say object 1 has a higher temperature, example like 71 degrees Celsius, and object 2 maybe is at 14 degrees Celsius. So the heat flow will be from this direction, okay, from higher to lower until both reach the same temperature. Okay, let's go on to the next questions on application. Okay, what I have done here, initially there's only 2 black lines, as you can see here. So what I did is actually I asked students to use their highlighter to darken one of the lines to aid, okay, make it more obvious, darken the line. So initially it was this, okay, in the examination, this was the 2 lines, a dotted line and a solid line. So let's try this. I give you a few minutes to try it before I continue the revealing the answer. Let me pause first. I stop recording for a while. Okay, let's continue to see these questions, which I have put it here. So what I advise students is they do some annotation. As you can see here, I've annotated here. Okay, firstly, they must understand this part, the temperature, the vertical axis represents temperature and the horizontal axis represent the time lapse. So there are 2 substances. You can see the 2 colors here. Okay, there's one important information which I've highlighted here. Please do so if you have not done. Y and Z were in solid state at 10 degrees. So look at here, this part is 10 degrees, isn't it? So what I advise students to do, use a pencil, draw a horizontal line to see the point where they intersect the line of substance Y and substance Z and make a cross here. Okay, can you see there's a cross here? So at this point, that means at 10 degrees, both of these substances, they are in their solid state. Okay, the other concept they need to understand is when a substance changes state, for example, solid to liquid is melting, right? So during melting, the temperature will remain constant. So that's why I asked them to write it here. At this part, at the 10-minute, substance Z is starting to melt. So they indicate Z is melting here. And similarly at here, at this part, at the 15-minute, Y is melting. Because you see the original graph here, at this part here, can you see? This part, and it is a horizontal line. That's means at the 15-minute, substance Y is starting to melt. It melts for 5 minutes, then the temperature increase. So annotation is important. So by doing that, actually you can get the answer very fast. You can see that at what happened at 20 degrees. So at 20 degrees, you draw a line across. Okay, let's look at substance Y, because the temperature is still increasing, right, isn't it? Until 30 degrees, then it starts to melt. So that's means at this point, substance Y is a solid. What about here? At 20 degrees, if you draw here, at this part where I put a green cross here, it already passed the point where Z is melting. That means Z has became a liquid at 20 degrees. So because of that, it's a liquid. Okay. So next one, describe what is happening to substance Z between 20 and 25 minutes. If you can see here, substance Z, if you see the original graph, okay, 20 minutes and 25 minutes, the temperatures remain constant, isn't it, this part? So actually substance Z melts at 15 around here. So it becomes a liquid and it reaches here, the temperature remain constant. So this one is a change of state. Temperature remain constant where it's still gaining heat. So for this question, we can say that substance Z is boiling, but because they say describe. So if you just put the word substance Z is boiling is not sufficient. So you must tell me what happens during boiling. Okay. So for this question, you should say Z is boiling. Okay. It gains heat and changes from liquid to gaseous state. Okay, in case you can't spell the word gaseous, right, you just say it changes from a liquid to a gas. Okay. Z is boiling, it gains heat and changes from liquid to gaseous state. Okay, next part. How long did substance Z gain heat? Okay, this one you need to be careful. If you refer to the original graph, substance Z is this part, right? The solid line. So can you see from 0 minute, it keep increase, then stabilize, and then increase again, and then stabilize, up to 25. Then after the 25th minute, it start to drop. Because some students, if they are not careful, they may put 20 minutes. Okay. Because during this part where it's boiling, it is still gaining heat. So therefore, this answer is substance gain heat for 25 minutes. Okay, 25 minutes. Why 25? Because you can see after 25, then it starts to drop. But I got to explain. So you should say that from 0 minute to 25 minutes, the temperature of Z is increasing or remaining constant, remains constant during melting and boiling. See, its temperature only begins to drop after the 25th minute. Okay, so this part, that's why the answer you need to explain. From 0 minute to 25 minutes, the temperature of Z is increasing or remains constant during melting and boiling. Its temperature only begin without S, only begin to drop after the 25th minute. Okay, so this is quite a good question on heat gain and heat loss. So once again, just to highlight this part, it's good to annotate with different colors because your PSLE exam paper is printed in black and white. So you use your stationery, either highlighter or other color pens to differentiate two lines. This will increase your observation skill. Okay. So I will proceed to the next question after I pause the recording for this.